And the next talk will be on Zoom, remote, by Peggy Varnière from APC in Paris. We'll talk about exploring the detectability of pre-circumbinary disk system.
Is everything all right? Can you hear me and see?
It's perfect. Thank you.
Okay, great. So I will talk about those pre-circumbinary disk system and focus on how are they detectable. So this is also a numerical simulation talk. The first thing is, what is a pre-circumbinary disk system? So when you think of pre-merger system, you often come to mind is the nice simulation we had just before, where you have two black holes with their individual accretion structure and a circumbinary disk. But this stage is actually an already advanced pre-merger stage. And so if we want to go to the earlier stage, it's really before any circumbinary structure and the pre-circumbinary disk name. And you have two distant black holes with their own individual disk that they would form with. And as they slowly in spiral, you have the impact of each secondary object impact the other object accretion disk. And the first reason we looked at the system is because they are the initial condition of the circumbinary stage. So we were interested to see what does the circumbinary disk remember of the initial condition like that. But we actually also focus on what is the potential detectability of the system. And just to be complete in the other direction, as was also mentioned earlier, is when you only have one circumbinary disk, no space for any kind of individual accretion disk. You can have some individual accretion, like a stream going to each black hole, but the disk system is really the far away circumbinary disk. So all of that, we talked only on dynamical timescale, what happened to the two black holes as they go, but we want to observe those systems, so we need to have the human timescale, especially with respect to LISA. And so what we see here is that if we expect a detection from LISA a few months before the merger, for the lowest, like 10 to the 3 and lower solar mass system, they would be have more chance to be in this pre-circumbinary system. And so if we want to identify them through their electromagnetic counterpart before the merger, we need to characterize those pre-circumbinary system. Even more interesting, if we are trying to find them now, the black hole that will merge in 10 years when LISA will be able to see them, we see that then it's up to 10 to the 6 that some of the system will spend at least the next few years in this pre-circumbinary stage. And if we want to even go further and use archival data way ahead of LISA, we see that in the last 100 years, a few systems up to 10 to the 7 have been in this pre-circumbinary stage. So it's really a stage that is important to study if we want to make observation way ahead of LISA. And so the problem is, like, how do you find their emission and their characteristics? Because the aim that we have is to find something that can say, oh yes, that's a pre-circumbinary system. This one will merge in 10 years. And so what we did is that we used our numerical observatory and plug different model in and run simulation, then did a full ray tracing in GR to get what will be the observable spectrum and light curve. So this is the setup of our numerical simulation. You have the central disk, like binary, the secondary black hole orbiting around. So we did a series. So these are all of the aspect ratios that we study several order of magnitudes, and a few 10 to the 3 RG1. All of the dimensions are based on the mass of the black hole 1 for simplicity. And so you see this very nice disk, and those are extremely typical of the gravitational impact of a secondary disruptor. And so what are those? I don't know if you see very well the spiral wave forming and evolving and rotating here, but there is a two-arm spiral in the primary's disk. This could lead some variability, but we don't know how strong is the gas, so we don't know. And also spiral waves are pretty common in astrophysics. And so they probably cannot be the smoking gun of finding the system. They are just too common. The other effect we can see from the simulation is the elliptical shape of the outer edge of a primary disk. So this comes from the fact that the secondary black hole is in a circular orbit. So this is really the maximum ellipticity we can see. We see that it's about, for a few orders of magnitude in Q, it's about 0.6. But the problem is that the density in this region is very small. And so the impact on the observable is also very small. But both of the signals are at the secondary orbital frequency. And so this is a frequency that we can reach for the system, for at least some of the systems. So it's worth being an extra little indication if we have other indication that this is a binary. So now let's look at the biggest effect that we see. That is the fact that the primary disk is totally shrunken and the outer gas is stripped away by the presence of the secondary object. And what we see here is that for a lot of distances and separation between the two black holes, we have always this very strong and fast run to about the same distance with respect to the separation. So this shrinking happens on the merger timescale. It's very fast, the orbital time compared to the merger timescale. And if we go even further and look for all of the mass ratio we have, we see that it's very easy to give the position of the outer edge of the disk with respect to both parameters of the binary black hole. So we have an extremely strong and feature that is the absence of that disk, and it's totally relatable to only and simply the black hole parameter. So now what we need to do is to look at how this missing outer disk impact the SED, and to see if this can be used to identify pre-CBD system. And so we first look at just that. And what you see here is that for most of those black holes, it's mostly in the infrared, optical and UV component for some of the lower mass supermassive black holes. But the problem with that is that the shrinking happens on the merger timescale. So what we see here is that it will be extremely hard to see any change of this air out, the lowering of the infrared flux for the IMAS system. It's happened on a too long of a time scale. But on the other hand, as we saw earlier, intermediate mass black hole, here we come much easier for human timescale, and we can follow how the outer edge shrink. So the first line is about 50 years before the merger. The second line is 10 years, and then 2 years. And so what you see is that within 10 years span, we will be able to detect this dramatic change in the accretion structure. And what's also more interesting is that if you go even to lower mass, this is a 40 mass black hole, you see that you get an even more dramatic change for the slower masses. So this will be the last two lines here are within 4 years of one another. So we will be able to have only one instrument following that. So there will be no problem to have like bias between instruments. So this is really interesting. And even more is that as we follow this lower mass system and their outer edge shrinking, we can relate how the outer edge shrink with the time to merger. And so what we have is a test for intermediate mass and lower black hole in this pre-CBD stage. So this is only valid before there is any circumbinary structure. But that's not all, because even if we cannot follow the movement of the shrinking of the outer disk for the higher binary mass, this shrinking happened, and it is a necessary observable for a very large portion of the binary parameters. And so we should check all of the binary black hole candidate compatible with the pre-merger pre-CBD stage, that they have this missing outer disk. If we have them having a gigantic disk, they cannot be in this stage. And so even more interesting is that if you have an AGN with a relatively small outer disk, we could check for a potential companion or flyby. And so you find a disk. If you invert this relation, you can obtain a set of potential binary black hole parameters. We know where to look for this secondary. And we also have the binary periods at which we can see some kind of modulation. And so if we have this outer edge of the disk, very small, we can use that binary period to see if there is a modulation in the flux at this distance. So these can help search for new potential companion and identify new binary black hole candidate. So this really shows the strength of this necessary observable. It is not a smoking gun. It is not the only thing that can cause a shrinking of a disk, but it's really one step further to validate or find a new binary candidate. And just to conclude, this stage that is not often studied is really important if we want to perform especially archival data ahead of LISA launch. And we will need to see that a lot of the systems have been in the last 100 years at some point in this pre-CBD stage. And of those three main effects, the shrinking of the primary disk is really a necessary observable for a large portion, and we should check all the candidates for that. Thank you.
Thanks a lot, Peggy. We have time for a few questions. Yeah. Okay.
Thank you, Peggy. I was just wondering, actually, you were talking about this. Are you familiar with changing look AGN?
Yes,
Yeah.
I'm planning to look at them more seriously once all the paper are like submitted and stuff. But yes,
I mean, it's not clear what the origin is of this changing looks in the AGN, and I was wondering maybe if this could perhaps influence some of these objects.
Yeah, I mean, it could. For the moment, I haven't looked at observation except for this one object that I use here at my that we found that had a smaller disk. That's the only system that I have looked at. I haven't looked more carefully into the observation at the moment, but the changing look at the AGN are some of the ones that I intend to target.
Cool, thanks.
Yeah, hi, nice talk. I was just curious. So basically, by missing outer disk, you essentially mean the tidal truncation of the companion.
Yes.
I'd assume, yeah. Do you have a specific way in mind through which you can probe the black hole binary candidates? Like, for instance, looking at the narrow line or broad line region size?
I haven't looked at, like, I am not an observer. I really like, my aim coming here is to show that to observer and said, if you have idea, I can give you simulations and data, but like looking at line and the impact it can have would be interesting, but this is not something we have done at the moment. Like we really focus just on the simulation. The paper has been accepted like yesterday or the day before, so it's really just recent. We are now starting to see what could be other observable. We are in particularly at the moment, we are looking at the part that I didn't present here, that's focused on, is there anything characteristic about how the inner edge of the disk behave with respect to the binary?
Okay, thank you, Peggy. We have time for 1 or 2 questions. No? So if not, so thanks again, Peggy, and move to the next talk.